Hey, this is a video for 9.1, Stratospheric Ozone Depletion. So go ahead and check out the overview and set up your guided notes. So just to review, we have in the troposphere ozone, and tropospheric ozone is a secondary pollutant that is formed through the actions of, or through the nitrogen oxides and volatile organic compounds when it reacts with sunlight. It is a secondary pollutant that is a respiratory irritant in humans, but it can also damage DNA in plants, leading to decreased rates of photosynthesis. Now in the stratosphere, the ozone layer is beneficial. This is because ozone blocks ultraviolet radiation from the sun. It doesn't do a great job of blocking UVA, which is why UVA can pass through the ozone layer. But UVB and UVC are pretty blocked by the ozone layer. UVC doesn't get through the ozone layer, but UVB is mostly blocked. Now, for humans, that means that if UVA gets in, this leads to skin aging. And this is also the one that is causing us to get suntan and sunburn. UVB will lead to skin cancers, which is exactly why people with light complexions like myself need to wear UV protection when we go out into the sun. And if the UVC got in, we would have severe burns. Now, environmentally, they all can disrupt photosynthesis. UVB leads to DNA damage, but UVC is very toxic, cytotoxic. It will lead to sterilization because it destroys the DNA and kills the cells. So we are very beneficial for the ozone layer because it prevents these UVC rays from getting to the Earth's surface. Now, the chemistry that happens in the ozone layer is very similar in the stratospheric ozone that it is in the tropospheric ozone. The sun's rays hit an ozone molecule and releases that oxygen radical, which can then form an oxygen molecule. It can also hit the oxygen molecule, releasing those radicals, and then forms ozone with the oxygen molecules. But we have a class of compounds known as chlorofluorocarbons, or CFCs, and they're used in refrigerants from air conditioners and refrigerators, but also can be used as propellants in aerosol cans, like hairspray and deodorant and air fresheners. They are not used as propellants pretty much anymore. There are some situations where they may be used for industrial purposes, but for household purposes, we don't have CFCs in our products. We'll talk about that in a little bit. Now, CFCs are very damaging because when the sun hits the carbon or the chlorofluorocarbon, it releases a chlorine ion, a chlorine atom, and that chlorine atom is very disruptive because it can break apart the ozone and then cause the ozone to dissociate and make oxygen. And remember, oxygen is very stable. So these chlorine atoms are working very fast, and they can actually destroy a whole bunch of ozone molecules. In fact, one chlorine atom can persist for 50 to 100 years, and it can destroy 100,000 ozone molecules. Now, if you look, the sun's rays are still breaking apart the oxygens, but once you put the chlorine in there, it is very difficult to keep up with that. So it doesn't take a lot, and they're very long-lasting and very damaging. We're going to be doing an activity in class that will simulate this, but you really do need to know the chemistry for this. So, normally, there is natural ozone depletion in the Antarctic region, and that occurs in the fall. Because what happens is there are situations where high up in the stratosphere you can get stratospheric clouds. Now, I know in previous lessons we said that all the weather happens in the troposphere. This is the only exception. But in the stratosphere, we can get different clouds forming, which has natural ozone depletion during Antarctic spring, which is around the month of October. So this represents the ozone layer over Antarctica. And scientists started noticing that there was a hole in the ozone layer in the 1980s. And this is when CFCs became banned. We'll talk about that in the next video. But you'll notice that as the year progressed, as we reach Antarctic spring, the hole gets slightly thicker, and then it gets a little bit thinner as we head towards Antarctic summer. Now, this is because of these polar stratospheric clouds. They contain water vapor, or, little ice particles, and nitric acid. And this is happening when it is super cold. And it is super cold and very, very cold temperatures in the stratosphere. Now, it releases a chlorine radical, and this chlorine radical can then serve to start dissociating and then break apart the ozone molecules. Now, you do not have to know the chemistry. You just really should understand that in Antarctic spring, there could be cases of chlorine atoms being released in the stratosphere that can naturally destroy ozone. But this is a seasonal event, and it usually is balanced out by the other actions in the other seasons. So this is what's happening when chlorine dissociates. You have a chlorine atom dissociates into chloride ions. And these are the chloride ions that are very damaging to ozone. Okay, what I would like you to do is respond to this check for understanding. And for free response practice, I want you to explain how CFCs contribute to the destruction of stratospheric ozone. I hope that this video is informative. I thank you for your attention, and I will see you soon.